You sent us down a truly mind-bending path with this one.
Oh, yeah. Which one?
The idea that our whole universe might actually exist inside a black hole.
Ah, right. That one.
Yeah.
It's wild stuff. Sounds like pure sci-fi, doesn't it?
Totally. But apparently some new observations are making scientists actually take another look.
That's right. I mean, look, the Big Bang is still our best explanation for how things started. It's got a lot of evidence.
Sure, the standard model.
Yeah. But science is always moving, you know? There are other ideas out there, alternatives. And the data we're getting now, especially from the James Webb Space Telescope, well, it's making us look at some of those alternatives again, with fresh eyes, maybe.
And that's exactly what we're digging into today. You shared this really interesting YouTube clip from Space Today with Sergio Sacconi.
Good channel.
Yeah. And he was asking, basically, could these Webb findings, these specific ones about early galaxies, could they actually support this universe in a black hole idea?
It's a huge question. So yeah, let's try and unpack it.
Okay, let's do it. So the video, it really zooms in on what James Webb can do, right? Peering back into the dawn of the universe.
It's incredible technology. And this study looked at 263 really early galaxies. And the amazing part is they were bright enough.
Yeah.
Bright enough for astronomers to figure out which way they were spinning, rotating.
Okay, and this is where it starts getting weird, isn't it? Because our usual understanding, the standard cosmology,
right, the assumption,
it assumes everything's kind of the same everywhere on the bigger scales, uniform, isotropic.
Exactly.
So you wouldn't expect galaxies to mostly spin one way, right? Whether you're looking way back then or now, it should just be random chance.
Precisely. The long-held view was basically 50-50, half clockwise, half counterclockwise, random spins. And that randomness should have been there from the start, all through cosmic history.
But Webb seems to have thrown a bit of a wrench in the works there.
It seems like it might have, yeah.
The researchers found a pretty noticeable difference in how these really old galaxies were spinning. The numbers weren't 50-50, were they?
No, they weren't. So out of these 263, they found 105, it's about 40% spinning counterclockwise.
Okay.
And the rest, 158, which is 60% were going clockwise.
60-40. That doesn't sound very random.
It's statistically significant. I mean, it suggests it's probably not just a fluke, you know?
Yeah.
So what this hints at is that maybe the very, very early universe wasn't quite as chaotic, spin-wise, as we've always pictured it.
Huh. Okay, so if it wasn't random, what are the scientists thinking? What's the interpretation of this imbalance?
Well, this is the fascinating part. Their thinking goes something like this. If this pattern, this rotational skew, is real and reflects how the early universe was structured, it might mean the universe actually started out more orderly in terms of galaxy spin. Maybe there was a preferred direction early on. And then over billions of years, things got more mixed up, more random.
Okay, interesting. More order turning into chaos. And this is where it starts connecting to some less mainstream ideas about the universe's shape or origin. The clip mentions something about a cosmic axis.
Exactly. Yeah, some cosmological models, alternatives to the standard one, they do propose this sort of underlying structure, maybe a large-scale axis.
Like what kinds of models?
The video mentioned a few. An ellipsoidal universe, kind of stretched, not perfectly spherical. Or a dipolar or bipolar Big Bang, where the initial expansion wasn't perfectly uniform in all directions.
All right.
And also certain types of what's called isotropic inflation. In models like these, you might actually expect galaxies on the grand scale to show some alignment or preferred rotation along an axis like that. They build in a kind of directionality from the start.
Right. Unlike the standard Big Bang, which is meant to be the same everywhere you look.
Precisely.
Okay, so back to the big idea. If there was this preferred spin direction early on, like the Webb data might be hinting, how does that link to our universe being inside a black hole? Where's the connection?
Okay, so this is where that theory comes in as a potential explanation. It's still very speculative, mind you.
Of course.
But the basic idea is that maybe our universe didn't just pop into existence, but it originated with rotation. Think about a rotating black hole at its very center. You have the singularity, that point of infinite density.
Right.
If our universe somehow emerged from something like that, maybe inheriting its spin, well, that initial rotation, that angular momentum, could have sort of imprinted itself onto the first things that formed, like these early galaxies, giving them a preferred direction to spin in.
Wow. Okay, that's a lot to wrap your head around. Like the physics inside a black hole could give rise to us.
Right.
But the video was clear, and you're saying it too, this one observation. It's not proof, is it? We're not throwing out the Big Bang textbooks just yet.
Oh, absolutely not. No way. Look, the Big Bang Theory rests on decades of evidence.
Yeah.
Cosmic microwave background, primordial elements, universe expansion, loads of stuff.
Right.
This universe in a black hole idea, especially as an explanation for this specific Webb finding, needs way, way more evidence. This observation is, let's say, tantalizing. It's really interesting. But it's just one piece, the very first step.
So what's next then? How do scientists follow up on this? The clip mentioned using the Doppler effect.
Yeah, that's a key next step. Using the Doppler effect, how the pitch of sound changes if the source moves towards or away from you. Light does something similar with color, shifting red or blue.
Red shift and blue shift, right?
Exactly. So they can use that to measure motion very precisely. They'll use Doppler and probably other techniques too, not just looking at spin direction, to dig deeper. The Doppler effect is really crucial because it can help separate a galaxy's overall movement through space from its own internal spin.
Ah, okay. So you can be sure you're actually measuring the rotation itself.
Right. It helps confirm if this spin preference is a real large-scale feature or, something else going on.
And let's say it holds up. If more evidence comes in supporting this early universe spin pattern, what are the bigger consequences? The need to recalibrate cosmic distances came up. Why is that a big deal?
It's a huge deal. Measuring distances across the universe, especially to really faint, faraway objects, it's incredibly difficult.
Foundational, though.
Absolutely foundational. Our entire picture of cosmic history, how fast the universe expanded, how old it is, the properties of distant galaxies, quasars, it all hinges on getting those distances right.
Okay.
So if the early universe had a different structure, maybe this inherent rotation, or behave differently than our current models assume, well, that could mess with the standard candles or the rulers we use to measure those vast distances. We might need to adjust our calculations, revise the distance ladder, essentially.
And that connects to another big mystery, doesn't it? The Hubble tension. Could tweaking distances help with that?
That's the really intriguing possibility, yeah. The Hubble tension is this annoying disagreement we have, right?
Annoying for cosmologists, anyway.
Huh. Yeah, definitely. It's the difference in the measured expansion rate of the universe today, depending on how you measure it. Looking at the early universe, like the CMB, gives one number. Looking at closer, more recent things like supernovae gives a slightly different number.
And they should match up.
They really should, according to our standard model.
Yeah.
So if, and it's a big if, we needed to adjust our distance measurements to the early universe because the structure was different, maybe involving this rotation, well, theoretically, that adjustment could potentially help reconcile those two different expansion rate measurements. It might close the gap.
So, okay, while the universe in a black hole idea is the flashy headline,
it grabs the attention, for sure.
The real scientific development here is this unexpected observation from Webb about early galaxy spins. And the black hole thing is just one potential explanation being revisited because of it?
That's exactly the right way to frame it. The JWST data has given us a surprise. A new clue about the universe's baby pictures, basically.
Yeah.
The universe inside a black hole concept wasn't invented for this. It's been around, kind of on the fringes. But this observation gives it a new angle, maybe some circumstantial evidence that makes it worth investigating much more seriously. But nobody's claiming victory yet.
It's more like, this old weird idea might actually fit this new weird data.
Pretty much. Ultimately, what it points to is a possible, very deep connection between black holes, arguably the most mysterious objects we know, and the origin and structure of the entire universe itself. It challenges our most basic assumptions.
It really does. It just shows how much we still don't know about the very beginning, doesn't it? It's quite humbling, really.
Incredibly humbling. The quest to figure out where we came from, what the universe is, it's ongoing. Always full of surprises.
Yeah.
Always forcing us to rethink. This is just the latest example showing our current picture, while powerful, isn't complete.
So wrapping this up then, what's the main takeaway for listeners from this deep dive?
I think the key thing is James Webb saw something unexpected, a pattern, not randomness in how the very first galaxies were spinning.
Right, not 50-50.
Not 50-50. And the surprising result has naturally reopened discussions about alternative origin stories for the universe. And one of those, this idea of our universe being inside a black hole, kind of aligns with this notion of the universe being born spinning, which is what black holes do.
But very much step one. Early days for this line of research.
Absolutely. Tip of the iceberg stuff. Scientists now need to do a lot more observing, a lot more modeling to see if this initial finding holds water or if there's another explanation. It's going to be fascinating to watch unfold.
It really is. And it does leave you thinking about some massive questions, doesn't it? Like, okay, if our universe is inside a black hole, what does that even mean for what black holes are? Could, like, every black hole contain another universe?
See, that's where your mind goes. It's unavoidable.
The scale is just astronomical. Literally, it pushes physics to its absolute limit.
It forces us to confront those limits,
Yeah.
What happens under those extreme conditions?
Yeah.
What are the fundamental rules we just don't know yet?
Well, thanks for walking us through all that. Seriously thought-provoking stuff. Definitely gives us a lot to chew on.
My pleasure. It's always fun to explore these big cosmic puzzles.